Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about the various questions that may be coming on communicating data. So, in principles of data science subject. So, the very first question is that what is discussed in detail about the various methods and rules for presenting the data. So, for presentation of the data, some of the principles what we are going to be follow is that the data should be arranged in such a way that it should be arouse some create some interest in reader, and the data should be made sufficiently concise without losing its important details, and data should be presented in simpler form to enable the reader to form the quick impressions and to draw some conclusions directly or indirectly, and it should also facilitate for further statistical analysis. So it should define the problem and suggest its solution. Okay, so these are some of the principles of presentation of the data. So the data what I'm going to present it should be able to create some interest in reading it, and should also be made sufficiently concise without losing its important details, and the data should be presented in simpler form, so in order to make the quick impressions and drawing conclusions quickly directly, and you should also facilitate the further statistical analysis, and you should also be able to define the problem and suggest the solution. So what are the various methods of presenting the data is that, so there are two ways of presenting the data. So first one is tabulation and another one is charts and then diagram. So demonstrate various charts and diagrams for presenting the data. So for that, we're going to have different types of charts and diagrams. So very first one is a bar diagram, histogram, frequency polygon, cumulative frequency curve, scatter diagram, line diagram, and pie diagram. So all this one is some of the diagrams we're able to apply for qualitative data, and some of the diagrams is able to apply for quantitative data. Okay, so normally data will be of two types. So some charts is going to be applied on this qualitative data, and some charts is going to be applied on quantitative data. So the bar diagram and histogram is going to be used for the qualitative data, line diagram and pie diagram, and histogram, frequency, cumulative frequency, that's and all is going to be applied for the qualitative data. Let's see one by one. So bar diagram. So there are different types of bar diagrams are available, like simple bar, multiple or compound bar, and component or proportional bar diagram. So widely this should be going to be used for comparing the data of mutually discrete data, and there are different types of categories are going to be indicated on x-axis, and frequency of the data in each category should be on another axis. So where the length of bar is going to be indicate the magnitude of the frequency of character, and the space between the bar should be almost or equal to the top bar here. So this should be the simple view of the bar diagram. So here on x-axis I'm going to take the diseases that is on x-axis, and then how many number of people are going to be affected, that is frequency I'm considering on y-axis. So the space in between each and every bar should be same, and at the same time the length of the bar is going to indicate how many number of people is going to be suffered this kind wax disease and falciparum and then mixed malaria. So like this we can able to construct the bar diagram. And next one is multiple bar chart. So this one is going to be used when the observations are going to be more than one, and should be represented by the group of bars. So okay, so the presentation of males and females in different countries, and percentage of deaths from heart diseases in old and young, and mode of delivery in different female age groups. I want to show it. Then I have to go for the uh, multiple bar diagram. So previous diagram I am showing only how many number of people are separated, got affected by these diseases. Now I want to segregate how many number of males are there and how many number of females are there for a particular kind of disease. Then I can able to show for multiple bar diagram. So here the blue one is going to indicate the number of male people, and red is going to indicate the number of female people. So like this, we can able to differentiate the attribute of more than one. Then we have to go for multiple bar diagram. And next one is that component bar diagram. So here, this kind of bar diagram is able to divide the bar into so many number of different sections. And for example, the two communities are going to be compared in proportional energy. Then I can able to uh, represent various food stuff, and each bar is going to be represent energy intake by one community, and each component also going to be represented by different colors of shape. So like this. So this should be the representation of this component of proportional bar diagram. So here each bar is almost are equal. So the length of the bar should be same here. It should be matches to 100%. Within the bar itself, I can able to segregate the proportion of the segments. So how many number of people are going to be obtained energy facts, and how many number of people are going to be obtained red protein, and how many number of people are going to be obtaining carbohydrate uh, blue color. So this should be in case of your community. Similarly, what should be the proportion of the proteins, fats, and then carbohydrates in rich community, how it will be. So like this, I can able to segregate the data in the bar itself, which is going to be divided into different sections. Our next one is that histogram. So it should be very similar to the bar chart, with the difference that the rectangles or bars are going to be adherent without gaps, and it is going to be used to present the frequency table that should be the continuous. So here each bar is going to represent a class, and height is going to represent the frequency uh, in a class interval. Okay, so here how this one a bar diagram and then histogram is going to be different now. So the bar diagram and histogram is going to be a little bit different. So here each and individual bars is going to maintain the space in between them. So where here you can able to no space is going to between each and every bar, then it should be considered as a histogram. And at the same time it is going to show in between the interval levels here, and here there should not be in the form of interval. So look at this structure of histogram. So here this should be the range, so 100 to 110, 110 to 120, 120 to 130, 130 to 140. So within the, and there is no space in between each and every rectangle bar. So that kind of graph should be treated as a histogram. So once the histogram is constructed, so there should be another way of constructing frequency polygon from the histogram itself. So it should be the derivative of the histogram. So by connecting the midpoints of the tops of the rectangle histogram, and the line connecting the center of the histogram is going to be called as a frequency polygon. And normally this should be a special type of frequency polygon that should be called normal distributed curve. See here. So how this one is going to be constructed is by joining the midpoints of the rectangles. So once you constructed this histogram, so then only you can able to understand. So this should be the initial histogram constructed. So from this histogram, so what I'm doing that is, so I'm going to join all the midpoints of the rectangle bars with a straight line. So then after removing this bars, the curve what is going to be obtained, that should be called as the frequency polygon. The next one is that so cumulative frequency diagram. So what is this cumulative frequency diagram? So otherwise you can able to call it as a view. Here the frequency of the data should be represented in each category, and the cumulative frequencies are going to be plotted against the opposite the group limits of the variable, and these points are going to be joined by the smooth free hand curve in order to get the cumulative frequency diagram or OQ. So what is going to be say that is here the frequency uh, diagram or OQ, it should be the frequency data, so which is going to be constructed from cumulative frequency curve, so it should be constructed from OQ. So here OQ means that, so here we am going to how to construct this OQ. So this OQ is also going to be constructed from the histogram itself. So but we have to be shown in the form of shaded region of that curve, that area that lies it. So that should be the presentation of OQ. And scatter plot or dot diagram, so this one also called as a correlation diagram. So normally this is going to be useful to represent the relationship between the two numeric measurements, and each observation is going to be represented by point corresponding to its value on each axis. So here the scatter diagram also called as a correlation diagram. So normally this one is going to be useful to represent the relation between the two numeric measurements, and each observation being represented by a point corresponding to on each axis. So whereas in negative correlation, so the points that is scattered in downward direction, meaning that so the relation between the two sided measurements, it should be the controversial. So if one thing is going to be increased and another thing is going to be decreases. So while as in positive correlations, the points will be scattered in upward direction. So this is the representation of a scatter diagram. So in this diagram, so what I'm going to say that I can able to mark this uh, dots. Okay. So once I marked these dots, then how to join all the diagram. So if I'm going to line a straight line, so the line on the points which lies below this should be negative correlation. The point which is above that line should be the positive correlation. And next one is that line diagram. So this is also going to be show the relationship between the two numeric variables, where the points are going to be joined together to form a line, and which is going to be used to show the trend of events in the past time period. So the line diagram, it should be the relationship between the two variables, but the points are going to be joined together to form a line, and which is going to show the trend of events with the passage of time. And pie diagram means that it should be consists of a circle, so where the area is going to represent the total frequency, so which is going to be divided into segments, and each segment is going to represent the proportional composition of the total frequency. So this should be the view of pie diagram. So here the circle is going to be considered, and this circle is going to be divided into three parts, where how much of percentage of people is going to be suffered from Vivax, and how much number of people, how much percentage of people is going to be suffered from falciparum. Like this, I want to show it. So then I can each and every color is going to represent one segment portion, which should be equal to the 100%. And next one is that, so discuss in detail about visualization. So what is the visual way to show the data? So that means the data visualization is the graphical representation of information where and data. So by using these visual elements, so like charts and graphs and maps, so these are the easier way uh, to provide an accessible way to see how to understand the trends, outliers, and patterns in data. There are three methods of data presentation. So first thing is the textual or descriptive presentation, tabular presentation, and then diagrammatic presentation. So these are the three methods that are available to represent the data. So first one is textual presentation, and descriptive presentation is one thing, and the same data I can able to represent in the form of a table, and then same thing I can able to represent in the form of a diagram. So these are the three kinds of data presentations. And what are the five methods of data presentation is that? So there's some of the popular ways of presenting the data like line graph, column chart, box plot, vertical bar, and then scatter plot. So these are some of the ways of presenting the data. Why are visual representations important in presenting the data? So data visualization is going to the data visualization is going to give us clear idea of what information means by giving it a visual context through maps or graphs. So this makes the data more natural for human mind to comprehend and therefore makes it easier to identify the trends, patterns, and outliers within the large data set. Okay. Uh, so the data visualization is able to give us a clear idea of information. So by giving it a visual context through maps or graphs, so this makes the data more natural for human mind, and it should be easier to identify the trend patterns and outliers within the large data set. And what are the five formats for visual display of the data? So in that one, first one is column chart. So this is one of the common type of data visualization tool. And in bar chart, unstable bar chart, line graph, dual axis chart, Miko chart, pie chart, and then scatter plot. So these are the different types of format for visualization of the data. So explain the key principles of and effective data visualization. So in that we are going to have 7 key principles for effective data visualization. So first one is that uh, determine the best visual and then balance the design, focus on key areas, keep it simple and incorporate interactivity and then use patterns. So these principles are going to be make the data visualization to be effective one. So we determine the best visual. That means to begin with, it should be an imperative to understand the volume of data in hand, and at the same time, you can able to identify the aspects that you wish to visualize around the information that you wish to convey. So after this, we can able to select the best suited and simplest visualization format of our target audience and balance the design. So in this one, so this should be equal to the equally distributed visual elements across the plot, such as texture, how to consider color, shape, and then negative space. And so in balancing the design, so the visualization should be symmetrical or asymmetrical or radical, and the figure out the right balancing elements for which should be the best for visualizing the right data and focus on key areas. So in this one, so you have to ensure the key areas that is going to be well highlighted, and you have to place the data points towards the top left corner as user attention and should be drawn towards the quadrant. And next one is that keep it simple. So in this one, it should be able to ensure the visuals are going to be simple and easier to understand, and you have to be adding unwanted information to make it confusing. And keep in mind that the ultimate goal of data visualization should be the simplicity. And you may also build additional visualizations if you want to convey the more uh, multifaceted story. And next one is that incorporating interactivity. So in this one, you have to be display the visualization tools that infuse the interactivity into our graphs and then charts. And next one is that we have to make use of patterns. That means we can able to display the similar types of information like with the help of other patterns. And we should also be establish a pattern by using simpler chart types, colors, and other elements. And second one is that compare aspects. So that means we can able to display a side by side comparison of aspect to make the understand of data easier, and you should also align the data either horizontal or vertically so that it should be compared accurately. And next one is to explain the presentation of the data using tables. So here the presentation of data should be categorized in 2 ways. So first one is the table presentation and next one is visual presentation. So again, this visual presentation is further transferred into types like graphical presentation and diagrammatical presentation. So what are the various principles of presentation? So very first thing is that the data should be presented in simpler form and should also arouse some interest in reader, and all the time the presentation should be concise without losing its important details, and should also facilitate further statistical analysis, and then how to be defined problem and should suggest a solution. So tabulation is nothing but it should be a systematic and logical arrangement of classified data in rows and columns. So whatever the data we're having, so if the data is going to be represented in table form, then it should be easier uh, to read as well as easier to understand when compared to the text here. What should be the significance of tabulation? So it should able to simplify the complex data, and unnecessary details and repetitions is going to be avoided in tabulation, and it should also facilitate the comparison, and it should also give some identity to the data, and it should also reveal the pattern within figures which cannot see in narrative. Next one is rules of tabulation. So here the number can be assigned to the table, what we can able to call it as table number, and title should be given to the table and should be concise and self-explanatory, and the contents of table should be clearly defined, and the subtitle should be properly mentioned with columns and rows, and group intervals in rows and columns is neither too narrow nor too wide, and the units of measurements must be clearly wherever is going to be necessary, and no place should be placed to the left of the table, and there should be logical arrangement of table in table, data in table. So this should be a representation of the table. So where we can able to represent the title and the table number and headings to be mentioned, and the rows and the body of the table. So explain different types of table that are needed for data presentation. So in this one, types of tables. So here the tables are classified based on the purpose and then based on the content. So if it is based on the purpose, I can able to call it as a reference table and then text table. So based on the content means it should be simple tables or complex table. So again, these complex tables are further classified into double table, triple table, and multiple table. So like this, the tables are going to be classified. So simple and then complex table. So explain the presentation of data using graphs is another question. So in this one, so what are the various diagrams that are available for presenting the data? So if I'm going to consider the graph, so I'm going to have histogram, frequency polygon, frequency curve, OQs, and line graph. So whereas the diagrams should be bar diagram, it should be of different types like simple bar, multiple bar, component bar, percentage bar diagram, and duration bar diagram. And next one is the pie diagram. And what are the advantages of the tables and graphs? That means so they are should be very attractive and should they are going to give the wide bird eye view of the data, and it should be easily understood by a common man, and they should also facilitate the comparison of various characteristics. An impression is going to be created by them along with the long lasting, and theorems and results of statistic can be visualized using them. So the limitations, so they are visually aids, and they cannot be considered as an alternative for numerical data. So though these theories and results could be easily visualized by the diagrams, which cannot be brought in. Okay, and the diagrams and graphs are not accurate as the table data, so only the table data can be used for further analysis. So by diagrammatically and graphically, the missing presentation of observation may lead to the mislead information easily. So it is possible to create a wrong information using the diagrams and graphs. So explain different types of presentation of data using graphs. So in this one, we are going to see about histogram. So histogram is nothing but represented by a set of rectangular bars, and the variables that is going to be taken on x-axis, and frequency is going to be taken on y-axis. So with the class intervals, we can able to present the high proportion of class of frequency drawn. And notice that the total area of rectangle histogram represents the total frequency. And if the frequency distribution is going to have an inclusive class interval, so they should be converted in an exclusive type. And the mode of distribution should be obtained from the histogram. So this should be the view of the histogram. So I'm going to consider the class intervals in between 145 to 150, how many people, and 150 to 155, 155 to 160. So like this, I can able to mention the frequencies value. So from that frequencies, I'm going to be construct the histogram like this. And the mode of distribution should also be obtained. So the center of the graph is going to be considered the mode of the histogram. And frequency curve. So this frequency curve can be constructed once the histogram is constructed, and the variables and the frequencies should be taken on x and y axis. And the frequencies that is going to be plotted against the mid values, and these points are going to be joined by a smooth curve that should be called as the frequency curve. So the total area of the frequency curve represents the total frequency. So like this, we have to be construct the histogram. So once the histogram is constructed, we have to join all the midpoints of the rectangle drawn with a freehand curve. So the curve what we can able to obtain is called as the frequency curve. And frequency polygon. So here also this should be same, but all the midpoints of the rectangle bonds is going to be drawn by a free hand straight line. So this thing will be able to call it as the frequency polygon. So the total area under the frequency curve should represent the total frequency. So here in this, so here we're going to construct the histogram. So from the histogram, if all the midpoints are going to be joined with a smooth and straight line, okay. So then I will to call it as a frequency polygon. So let's take an example. So I'm going to have a salary in between 5,000 and 10,000, 10,000 to 15, 15 to 20, 20 to 20. So I can able to identify the number of workers in the range of that. So I can able to identify once this is constructed, then so this is first bar, and this is the second one, third one, fourth one, and the fifth one. So if I'm going to join all the 8 points of the rectangle and after deleting all this, so the polygon what I'm going to get this. Gives is the under cumulative frequency curve. So it should be a smooth curve which should be calculated among the cumulative frequencies plotted against the variables of class limits. So here the class limits are going to be taken on x-axis and cumulative frequency are going to be taken on y-axis. So there are two types of abuse. So the it should be less than the curve, or you can able to call it as one thing, and greater than the curve is going to call it as greater than. So less than cumulative curve. So the variables of value is going to be taken on x-axis and should be less than the values along the y-axis, and these points are going to be joined by smooth curve. And greater than of cumulative frequency is that. So here the variables values is going to be taken on x-axis, and greater than cumulative values are going to be taken on y-axis, and these points are going to be joined by a smooth curve. So like this. So once we drawn this, so this is one curve and this is another curve. Okay. So this the value which is going up should be called as the less than or weak curve, and the value which is falling down we should be called as the more than or. So how are we going to calculate the median from the overview? So one less than overview and greater than overview is going to be coincide at one point, and this point should be called as the median of this values. And line graph, so line graph is mostly used to compare the make the comparison between the two variables on x and y axis. And x axis is going to represent the measured time, whereas y axis is going to represent the percentage or measures of the quantity. And the line graph is going to be displays in the change of direction, and it should also shows the trend of event occurring over the period of time to know whether it is going to be increased or decreased. Suppose example of transcendence. So the line graph is mostly used in cricket matches to show the results of various teams. How the scores is done by India and Australia like this. So this is the one of the view of this line graph. So once we mark all the points, if all the points are joined by dots, and then it should be the line graph with respect to time. So these are some other example. So the retail prices of petrol and diesel along with the price of crude oil. So how this work. So explain the different techniques presentation of data using diagrams. So there are different types of diagrams are available. So pie chart, pie diagram, bar diagram, scatter diagram like this. So this one first pie diagram. So pie diagram is also known as the sector diagram. So how this one is going to be like taking a circle. So how to divide, how to calculate the angle. So how the angle is going to be calculated. So frequency by total frequency into 360 degrees. So the frequency of the groups are going to show in circle, and degrees of angle is going to denote the frequency and area of sector. And it should also give the comparative difference at glance. Okay, and here some part segments is going to be presented. So drawing the circle and find out the center point of the circle by make and draw the radius. So by make use of this protractor and make the segments of that pie diagram. So how to construct this? So we have an example like this. So I'm going to have a frequency of different colors. So how this one is going to obtain? So frequency is 6 divided by total frequency 40, it's divided by 40 into 360. So 9 6 are 50. So 554 degrees. So by making the protractor, I have to construct the 54 degrees. So similarly, how can able to get yellow here? So frequency by total frequency into 360 degrees. 90 degrees. So from this, I have to construct the 90 degrees. Like this, I have to construct the pi diagram. So this is another example. So we have so how to construct this. So these are the various expenditure and degrees of measurement. So by making the protractor, we can able to easily construct the pie diagram. And bar diagram. So the bar diagram is going to consist of different sizes of rectangle, different equal width. So one should be horizontal bar diagram, and another is that vertical bar diagram. So based on the need, we can able to construct either bar diagram or vertical horizontal bar diagram or vertical bar diagram. And simple bar diagram should be like this. So where the relation is going to be established along with the single variable, and all the bars is going to maintain equal space. So is the one of the view of this bar diagram, and this is another example. And subdivided stack or proportional bar diagram means so the bar is going to be constructed and then which is going to be splitted into different proportions. Okay, where this each color is going to represent the different sections of the bar diagram. So like this. So here the goals, red color is going to present the goals, percent of goals, how many number of goals completed this nursing degree, and blue color is going to be indicate how many number of boys completed the first BSc nursing degree course. And percentage bar diagram means that so here all the bars is going to have equal width should be mapped to the 100%, and each bar is going to be divided into different segments. Okay, so based on that we can able to construct it. So here the bars are going to be divided according to the percentage components. So like this is another example representing the stack bar proportion bar diagram. And multiple bar diagram. So in multiple bar diagram, so for a single variable, I have to show the different characteristics. Then have to go for the multiple bar diagram. So in 2009, so what should be sales of Desire cars, and then Tata cars, and then Fiat cars like this I want to show, then how to go for the multiple bar diagram, so that it should be make the comparison very easily, and you show where the rectangle bar should also equal to the width of the height of the proportion, and the diagram is going to be shaded properly of the index. So this is another example of the multiple bar diagram. Next one is deviation bar diagram. So deviation bar diagram means, so here this one is going to be used below. So if the bars is going to be drawn upward, then it should be positive. Where the bars is going to be down, that should be negative deviation. So like this, we can able to construct a positive deviation bars and then negative deviation bar diagram also. So based on this application, we can able to construct this. So this is another example of the deviation bar diagram. The other presentations of the data what we are going to have is that stem and leaf. So it should be a plotting a quick way to organize the large amount of the data, and it should be a special table where the value is going to be split into different leaves and then stem. So already I covered some of the videos on this topic, so I can able to go through it. So the stem is going to be values that should be listed down, whereas the leaves is going goes right to left of the stem leaves. So normally the stem is going to be used to group the scores, and each leaf is going to be indicate the individual scores within the group. So this is the example. Suppose if I am going to have the values, so we can able to call the stem. The values that is going left and right should be considered as the stem and leaf. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.